Thank you and welcome. As he said, my name is Eduardo Pozo. I'm a network automation architect working for companies in Norway. And today I'm going to guide us through yet another journey. But this time it's going to be a journey of automating our networks with Terraform. I'm also the one standing behind you and launch. So I will try to make this as fun as possible. And I hope that is something interesting for you guys. So let's start with our journey. Some want to deliver a ring to a mountain. Others just want to destroy a Death Star. But I think we have a harder journey ahead. We want to automate our networks. We need to open tickets, change infrastructure, and think about a lot of stuff that Frodo or the guys in Star Wars didn't need to think about. So let's start. The journey, we are going through a dream, or what do we want to do, the foundations, what do we need, the vendor maze, the sorcery of the state, scaling our tool, and one final boss. So let's start with assembling a team. And why do we need a team? When we as network engineers think about the network, we think about switches and routers. But in reality, for the clients, the network is everything that allows the PC to connect to the services or to the internet. It's not only network devices, it's also firewalls, maybe some servers, authentication, .1x certificates. So it's a bunch of stuff surrounding the network that allows the network services to work. And that's why we need a team, maybe a team of experts in different areas that allows us to do or to create this tool. So therefore, a full automation effort needs a team. Quick introduction to Terraform for those who have never heard of it or doesn't know how it works. It's an open source tool created by the HashiCorp. I say open source because it changed the license in the last year, but I won't go into details. The main difference with Ansible is that this tool is a stateful tool. It means that every time we create an object with Terraform, it's going to save the state or the configuration in a state file, in a storage. So every time we run Terraform again, it's going to compare this state with the infrastructure. And we'll always try to have a no diff. It will tell you we need to delete or we need to create objects to be able to achieve this state in the infrastructure. And it's also a graph or dependency base. That means that in Ansible, we go from top to bottom. In Terraform, we need to build dependencies between objects. So Terraform knows how to create or delete these objects. This is how it looks like. We ingest some variables into Terraform. It creates a Terraform plan that basically tells us this is what's going to happen or this is the diff. We say yes or no, and Terraform just goes and deploys into the infrastructure. We have some providers that are basically our Ansible collections. They are called providers in the Terraform world. It's basically the vendors or ourselves that make them. They are open source, and we create resources that are objects. This is how it looks like in code. We have some variables that we ingest in. Then this is how the Terraform code looks like. The plan, we are going to create a new interface VLAN with these variables. And this is how it looks when it's pushed to the network device. So if afterwards we change, for example, the description, the next plan will say we are going to change the description again, and then it's pushed to the device. Or backwards. If someone changes manually the description, on the next plan, we are going to overwrite what they did manually on the devices. That's what we mean with stateful. So again, this is our dream. Our dream for everyone in this room, I think, is to create this black box. The client doesn't care. They just want to send a request, API, somewhere, and then it's pushed into the network devices or to the whole network. It might be something as simple as one VLAN, or it might be a full service, like create a new location, a new data center. And we are going to try to create this black box. Let's set our foundations. When we speak about tooling, we speak about just making a script that can work in our laptops, right? To make our jobs easier. We don't care if it doesn't work in our friend's laptop. He can solve it himself. But we are going to create a tool. We need to think about many other things. Sync, log, storage, security, audits, uptime, SLA, clusters, Dockers. There's a bunch of stuff around, so this needs to be in place, or we need to at least plan about this before we begin. We have the state file. State file is now our golden egg. We need to take care of it because this is what basically the mirror to our infrastructure. If our infrastructure gets completely deleted, it blows away, it gets nuked, or it's a fire on the data center. With a state file, we can just run Terraform again, and the whole network, the whole infrastructure is going to be put in place again as it is declared on the state. And of course, we need an inventory. We need a place to fetch the data from. We are not Google, Meta, or Amazon, so basically we need to navigate a vendor maze. Google, Meta, and Facebook, they can create devices that are customized for their automation. We need to do the opposite. We need to create our automation for the devices that the vendor gives us. So then when we go out and ask them, do you support Terraform? Do you support NetConf? Do you support all this? They say yes, of course, because they want to make some money. They do support it. They have providers. But in reality, Terraform is more complex than just an Ansible module because it needs a better API. And we found out that all vendors, I'm not going to point finger, but 99% of vendors have half-baked providers. Some resources, you can create them, but you cannot delete them. Maybe you can create them, but you cannot modify them. Or they just crash and burn on the first try. Maybe they didn't even test them. We don't know, but it was a major problem. We found issues like 121 open bugs in a single provider, and some issues that were running for years, and no one took care of them. But we need to remember that these are open source tools. These are vendors that are making money, but still these providers are open source. So we need to get involved. Open issues, suggest fixes, try to also help them to help us. We can also do a hybrid approach. Automate these resources that can be automated or they work correctly. And for the ones that do not work correctly, use something else meanwhile, Python or just manual configuration. We can also do some forking, just fork the repository, put our own fixes into it, and use our own, basically our own provider. Of course, testing. Every single resource we had to test to be able to ensure that everything was working as expected. Let's go to the state. The sorcery of state. Again, this is a stateful tool. That means that if someone does a change manually on the device, we need to sync it back into the state, or we're going to overwrite this change. Sometimes it is okay to remove these changes because this is our state, this is what we want. But maybe there was an emergency window last night and they had to do some changes manually to be able to put things up. And then we need to put this back into state. So get ready to do CLI. Terraform has some CLI operations to be able to remove, modify, and apply single resources directly from the CLI. So again, we are trying to automate everything, but we are going to use a CLI. And at the end, the state is just a JSON file. So we can always go into the state file and do minor modifications. But of course, take a backup, please. Don't go to the state and go wild with the JSON because you might just break and corrupt it. Take a backup, do the changes that you think you might need, and then test again. Terraform has a very quick command that it's called Terraform destroy. As it sounds, it destroys everything that is on the state. Basically, you can wipe your entire infrastructure with only one command. Terraform destroy, auto approve. Goodbye. Everything is deleted. But one major thing about Terraform is that the Terraform apply command can delete things. Apply doesn't mean only push or create. Apply in Terraform means sync the state with the infrastructure. This means that if there is something on the infrastructure that is no longer in the state, Terraform will try to delete it. And that's why in these projects we created also a manual stopgap. We create a Terraform plan, then an engineer needs to review this plan to verify that we are not going to delete things that we don't want to delete, and then it gets approved, and then the pipeline keeps running. This is because this is running on a major healthcare provider and some oil rigs in Norway, so we don't want to lose billions or lose lives in the hospitals. So we need this manual stopgap in the middle. There is, sometimes it's easy to see that something is going to be destroyed or replaced. Here, it says this interface VLAN is going to be replaced because, of course, we are changing the VLAN ID. So this is going to be deleted and put back. OK, it's easy to read this plan. But sometimes it's not that easy. In this case, supposedly, we are destroying a single BRF from the BGP process. But because of how Cisco has coded this provider and how netconf or YAML model is made on this device, if we run this destroy, we destroy all the IPv4 address families on the BGP process. Basically wipes out the BGP process. Don't ask how we found this out. But it was painful the first time it happened. So how to avoid this? There is 2 ways or 3 ways. The first way, it's a tag on Terraform that says prevent destroy. Basically, it prevents this object from being destroyed. But that means that if you really want to destroy it, you need to go to CLI and do it manually, as I said before. Or also, you can do something called ignore changes. Like, let's say that you push an interface description via Terraform. But you don't care if that changes in the future. You care only about the configuration itself. Then you can say lifecycle ignore changes description. If someone changes the description in the interface, Terraform will just don't care or skip that check. Of course, the third way is to do a proper vetting of the plan changes. Now let's start scaling. Now we know how to do. We know how to create our Terraforms. The vendors are in place. Everything is working. We have tested. Let's start putting this in place. One major hurdle with Terraform is that it started, or it is a cloud tool that was in the beginning meant for decoupled objects. If we think about Amazon or Azure, we can create a VM and a storage. The order of operation doesn't matter. When we want to delete them, we can delete the storage and the VM is there. Or we can delete the VM and the storage is still there. It doesn't matter. But in networking, we have an order of operations. We cannot create a BGP neighbor in a BRF without creating the BRF first. We cannot create an interface in a BRF without going through a set of objects that we need to do in order. In Ansible, it's much easier because we go from top to bottom. But in Terraform, it's not that easy. As I said before, Terraform is a graph-based tool. So if we create a Terraform file that here, for example, is going to create a BRF, a neighbor, and an interface VLAN, and don't give dependencies, the Terraform graph, it looks like this. It has no dependencies between the objects. So when we run this file, Terraform will just try to create these objects in a random manner. So maybe we're lucky and they are created, but of course, if we try to create this one before this one, it fails. And we need to figure out what it fails. So the solution is to do this, depends on. This is something called explicit dependencies in Terraform. You go into one resource and say, this resource depends on this other one. So then the graph will look like the right side. We build our dependencies. So when we do a Terraform apply to create all this or to delete, Terraform knows which way to go and creates or deletes the objects in the proper order. We end up controlling the controllers. So we create an orchestrator to orchestrate the orchestrators. Many of these vendors call it Cisco with ACI, DNS Center, Palo Alto with Panorama, Checkpoint. Most of them have a controller that is made to control the network devices. And in many cases, they have features that can only be pushed via controller. So we cannot go directly to the devices and use these features. So we end up controlling these controllers. So the solution is to distribute when possible. Instead of having only one Terraform pipeline or process that goes through all these controllers, let's try to have different pipelines, different runners for each one of these different controllers. And if we can go directly to the devices, please do it. As other ones have mentioned, it's much better if these APIs are available directly on the devices. It's much better to go directly there than to go to a controller. So we have almost reached our dreams. We have a Git pipeline that is working. We have a Python script that fetches the integration from other systems and sends this into Terraform. We have the manual stopgap. We have everything in place. So this is how we think it's going to go. Easy. We have done this 1,000 times, and it works. But this is the reality. It's never as easy as we think. Why? Things take time. As others have mentioned with Ansible, we also have the same problem with Terraform. Let's say what we are creating, BRFs, routing, tenants, configuration, VLANs, ports, trunks, etc. Remember that Terraform needs to read the status of the object from the network device, then push the object, and then read again. If each API call takes 1 second, or let's say half a second to be really, really good, it still takes like 2 seconds per object. Multiply this for 5,000 objects, and you end up with a pipeline that can run for 1 hour, easily, just to create one VLAN. And why? Is because Terraform will try to read all the objects on the state before pushing something. So this is Terraform working. When we try to scale into thousands of objects, we can try to use parallelism to try to use more processes, but still we have an order of operations that we need to do. We cannot create the interface in parallel with the BRF. We need to do the BRF first and then the interface. So the solution, again, is to divide and conquer. For example, in Cisco data center case, Cisco recommendation is to use MDO or multi-site controller for everything. Do everything through MDO. It doesn't matter if it's local objects. And we said no. Why? Because this was being our bottleneck. For multi-site objects, we go through MDO. For local objects, we go directly to the APIC, which is the local controller. And for things that we can bypass the controller, of course we bypass the controller. Thank you. We don't need this controller. And the other solution is to split your state. As I said, Terraform needs to go through the whole state or all the objects. It will refresh them or read them again every time we run Terraform. So let's try to keep these states small. We can divide them in overlay, underlay, in tenants, layer 3, layer 2, and so on. We are free to divide how we want. There are many, many ways to do this division or to divide the states, different pipelines, different configuration, different variables. You can just Google it and you will find an answer. Again, everything is in place. We have divided. We have distributed the controllers. We have divided our state. Let's migrate again. Let's try. We are migrating a data center with 550 leaves, thousands of objects, and at least 2,500 VLANs. Don't ask me why they had so many VLANs, but they were there. No, still taking a long time. So this is our final boss. We are almost there, but it's still taking a long time. What's happening? 32 minutes to create a VLAN. Then we start digging down. We saw on the servers, first we tried to throw CPU and RAM to the servers, of course. More CPU, more RAM. Didn't help. CPU went to 100% all the time. What's happening? Then we dig down into the processes, and we saw that when the pipeline started, Terraform ate all the CPUs available, all went to 100%, but for the next 10 minutes, it didn't even start to contact the network devices. It was just doing something. And we were saying, but what's happening? And then we started digging down and went into the issues in GitHub for Terraform, and we found some old issues that says that the usage or some functions in Terraform were hurting the performance. So we started digging down there. What was happening is that Terraform, just as Ansible, have some functions that we can do locally in Terraform to transform our data, to do loops, deduplication, regex, dictionaries, and so on. It's the same as Ansible with filters and the local loops and all this complexity. But in addition to the actual code complexity, it seems like when HashiCorp developed Terraform, they didn't care too much about the performance of these functions. If we see on the right side, on the same Git issue, we can see that the distinct function, which is just a deduplicate function, has an exponential complexity. Basically, when you try to scale, things go really bad. I mean, it takes too long for them just to run this simple function. And we were passing in more than 10,000 objects to Terraform. We needed to do this because we were fetching data from different places. So there were some duplicate data, we needed to do some looping and so on. And when we started, we were doing this inside Terraform. When we saw this, we said, no, we need to move this outside of Terraform. So the solution was to move all the advanced, for me, the duplicate is not advanced, but let's call it advanced logic, outside of Terraform. So we end up from only having some Python that did the integration and the data ingestion to having another layer that did the data transformation. So we have some Python scripts that they run and fetch data from different systems, and we have another set of functions that take this data, do all the looping, the duplication, transformation, changing variables, and everything that is needed. So when we send the variables to Terraform, they are ready to be used. We don't need to do any more looping, no need to do any more transformation or anything weird in Terraform. They are ready to go. And we went from 56 minutes to deploy 6,000 objects to 7 minutes, only moving the data transformation to Python instead of in Terraform. So it was a major change that I hope HashiCorp can fix in the future, but I am also a little more comfortable working in Python than in HashiCorp, so I'm happy to be doing this in Python. So we have achieved the mountain. We achieved the top. We did everything we wanted. Now we have a platform that is up and running. It takes API calls from clients, deploys the Terraform pipeline, and deploys thousands of objects to data center, campus network, the health network, and in other clients, also oil rigs in Norway. What did we achieve? Did we save some time and money? I don't think so. And my opinion is that anyone who is trying to go into network automation thinking that they are going to directly save money, they are going to see the project as a loss. But indirectly, they are going to save a lot of money and time. Why? Because now we are enforcing standards. Name, addresses, configuration, design, security policies, everything is standardized. So we are 100% sure that all the switches and all the devices in our network are compliant with our design and our configuration. And if someone goes in and does a change manually, on the next Terraform run, we are going to override it. And we are going to find out who did it. We are going to save, or we are saving thousands, maybe millions of clicks in the GUI. For those who have worked with Cisco ACI, just putting one VLAN on one port takes at least 32 clicks. I counted. 32 clicks to put one VLAN on one port. So imagine doing this in a data center that is multi-site, has more than 500 switches, thousands of ports, and 2,500 VLANs. It was going to be impossible for operations to be able to operate this network without automation. We enforce policies, login, security. We know who did changes when. Before, it was a cowboy war. Anyone could go into a switch, do a change in a trunk, go out, no one knew what happened. Now everything needs to go through our pipeline so we know or we can enforce the security. And very important, we take out specific knowledge and make it general. The guys operating the data center, they cannot do ACI. They don't know how it works, but they don't care. They only care about sending us the data that we need, and we abstract everything that is needed in the Terraform pipeline and push the configuration to the devices. So we take away the specific knowledge. They don't need to learn about vendor-specific knowledge anymore. They just need to know what they want, the intention, and we abstract the vendor layer from them. And of course, we are modernizing and pushing forward. I prefer to write code than to go to 2,000 switches and update a switch per trunk. It's much better, at least for me, much more fun. And I also like to write code, so it's good. That's it.
Do you rerun your pipelines regularly, and if yes, how often?
The pipeline is triggered by changes. So anytime a change comes, a pipeline runs to deploy this change.
So no, like overnight to check, if everything okay, to keep it intent with the current state, nothing like this.
Yeah, right now we are in a phase that we want to have this stopgap because we are in the beginning of the project. So anything a change comes, someone needs to approve this change. The goal is for standard changes that we know that they are not going to break the network, we are going to automate them. So we are going to remove this stopgap, and they will just go through. So they can do change at midnight if they want. That's the goal.
Awesome. Thanks for presentation.
Thank you.
I have a question. Thanks for the presentation. I was wondering, how is your staging or testing? Because as Terraform being such a stateful tool, the tool needs to know a lot about the whole infrastructure, and I guess that's very fine for production, but I think you cannot have a test that is the same size as production. So how do you make sure that your tests are as close as possible to what you have in production without needing a one-by-one production in Terraform?
We have 2 layers of testing. The first test is a code layer testing. We have unit testing and integration testing of our code to verify that everything that we are doing is going to produce the data that we want. And when it is to test the actual modules or Terraform resources with the devices, most of our locations are standard, so they are the same. So we have a lab environment that has physical devices that we can just test there all the time, break it, rebuild it, and it doesn't matter. And in the last few weeks, we have been trying to spin up some also virtual instances for the things that can be virtualized, to also be able to do some CRUD testing. Like for each resource, we're going to test creating, editing, deleting, and then we destroy the controller or the switch. It's much easier when you have things that can be containerized in Container Lab or in CML or in some virtual devices. For those that cannot be virtualized, we were lucky, and the client just bought us an extra controller just to test.
So we use a lot of Terraform here for customers. And I think the one thing that's really important for this audience to understand is that when you're using Terraform, in some ways you could say the source of truth has moved to the repository, to the location of the TF state, and to the location of the Terraform files. And any operations that you make in the GUI or other tools outside of that can effectively stay in place and be mysteriously overwritten and removed when the Terraform apply runs, which may happen at some random time in the future. I was wondering if you had, I know obviously you encounter that, and if you had any ideas on how to figure out, if there are other changes going on in the environment, how can you pause the Terraform apply to have a human interact with that process and figure out, hey, there were some changes that were made in a GUI in an emergency situation, and now we need to backport them into our Terraform files. Have you thought through that loop process?
Yes, and that's a very good question. What we are doing right now is that when one of these changes come in, emergency change, something that had to be done and needs to be synced back, they need to tell us, we did this change on this location, we set the pipeline in pause. The downside is that no more changes can come in via automation while we do this sync. But also what we are trying to do is that we are trying to automate only the things that are really dynamic, right? Things that change continuously, new VLANs, new ports, new services, new access lists, new prefix lists, BGP neighbors, all this is automated. But there is a lot of stuff, at least in the health environment, that is really critical. For example, the connection to the WAN. If that is lost, the hospital goes down. So we decided to not automate that part. Because, of course, we have sort of good control because we made the tool, but a network operator that doesn't have full control. They might see a destroy in an interface. They don't know what it is. They go through, and suddenly the one BGP neighbor is down, and the whole hospital is down. So we need to keep a good balance between the automation and not automation. But short answer is that right now we set the pipeline in pause while we sync. In the beginning of the project, it happened more continuously. There was a lot of manual changes. But I think in the last 2-3 months, it has happened very little. Almost any change, it's going through the pipeline now.
My name is Thomas King. I'm from DKIX. Thank you very much for this great presentation. I have a question on the last slide. You're saying that there were no savings on time or money. I guess your CTO might not be happy with that. Being a CTO myself and looking on the automation, network automation projects we run, I think it's sometimes hard coming up with a comprehensive business case. Because usually, and this is most probably what you wanted to say here, and actually the question, is that what you want to say? That's very hard to come up with the savings that will be in a different team or different department, so the indirect savings, because the direct savings, I think this is what you're talking here about on this slide, right? That's very clear. You can directly comment on how much you spend on the team and how much you save on the team with these activities, but company-wide, it's a lot harder. And the question is, more like, it's a broad question, but the question for me as a CTO is, how can we come up with comprehensive business cases showing that this network automation investment will pay back for the company as such? And do I have an idea on this?
Sort of, yes, and you're correct. When I say no time or money saved, I was saying directly, of course, because if we look at the price of the people or the salaries or the consultancy and all the infrastructure we need to start, it has a price. And you don't see a direct money save or time save. But my answer is that for everyone that is trying to go into the automation or to deploy something, you need to look at it, as you said, in a more general, holistic way. Maybe the network automation itself is not going to make money, but it's going to make other people make money. And when it comes with this healthcare provider, I can say easily that before the automation was in place, it could take weeks, maybe months, only to deploy a single change to some switches, just because they are not too many people in operations and they are handling more than 60 hospitals. So that's where the time saving comes. So we are not saving time directly because we are using main hours to deploy the automation, but the operations team now can do things faster. And it's not only faster, it's secure. The configuration that they are applying is tested. We know that it works. It's not going to break anything. So that's where the saving comes from, at least in my opinion.
Thanks, Eduardo.